We're going to look at exothermic and endothermic reaction. A chemical reaction occurs so that elements can achieve a more stable energy state by gaining a full outer shell of electrons. This is done by chemical bonding, where old bonds are broken and new bonds are formed. This process involves the transfer of energy into and out of reaction mixture. The terms used to describe this are the system and the surroundings. Here is a system. There are two types of system, open and closed system. Open system where matter can go in or out of the system. But for a closed system, no matter can go in or out of the system. But heat can go in to and out of any of the system, because heat does not have mass, it has electromagnetic energy. Here is an open system where heat can go in or out of the system. But when heat predominantly goes out of the system into the surrounding, that means the system is hotter than the surrounding. That means the surrounding is gaining heat from the system. The exiting of heat is called exothermic. Thermic means heat, exo means exit. In this system, heat is going into the system. It means the system is colder than the surrounding. Endo means enter, thermic means heat. Enter heat is endothermic into the system. When you join two atoms together, it's called bond making. This is exothermic. Exothermic is bond making. It's also called fusion. You're fusing two atoms together. The reactant, because it's losing heat to the surrounding, the final product will have less energy. Hence, it's minus delta H. H stands for enthalpy. It means energy. When you break in a bond between two atoms, this is called bond breaking. It's also called fission. Because the final product will gain energy, it will have increase in energy by that amount. So it's called positive delta H. H is enthalpy. It means energy. This is the reaction profile for exothermic. The y-axis is potential energy and the x-axis is reaction progress. The reactant has zero potential energy and the product is lower than the reactant and it's minus delta H between the product and the reactant. The energy from the reactant to the top of the energy profile is called activation energy. We can lower the activation energy by using a catalyst. With the catalyst, the activation energy will go down. So that is the activation energy with catalyst. This is the energy profile for endothermic, the potential energy and the reaction progress. The reactant is always zero potential energy, and the difference between reactant and the product here is plus delta H. As you can see, it is above zero. That's why it's plus. Unlike here, the product is below zero, so it's negative. The distance from the reactant to the top of the reaction curve, that distance here is called the activation energy, and the activation energy can be lowered by a catalyst going from there to there, and that height is called activation energy with a catalyst. In both cases, R is the reactant and P is the product. Example of exothermic reaction: 1. Combustion. 2. Burning. 3. Oxidation reaction. 4. Respiration. 5. Neutralization reaction. Example of endothermic reaction: 1. Electrolysis. 2. Thermal decomposition. 3. Photosynthesis. 4. Citric acid and sodium hydrogen carbonate reaction. 5. Cold packs, spot injury treatment. A displacement reaction can be exothermic or endothermic.